Okay, here we are back at problem number 15, as it would sort of look like on an FRQ, except you'd have more spaces between all these choices. And we've taken care of A and B. Now we can go on to C. Let's focus just on C right now. Here I've got it. Write the net ionic equation for the reaction between the weak acid, and this is something new, a strong base, sodium hydroxide. Well, I've written the reaction to indicate that hypochlorous acid is a weak acid. You should know that even without my saying it or putting it in the question. If this, you're going to have an AP question where they presume that you would know this in the first place, that it's a weak acid. And the same thing here with the sodium hydroxide. You should realize that hydroxide is a strong base and wouldn't have to have me prompting you for this. Well, let me answer the question right now. And we'll do that by writing out hypochlorous acid dissolved in water. Now, this is a molecular substance. It stays that way mostly. And we're going to add it to sodium hydroxide aqueous. This is a strong base. So the next thing you should write is a arrow rather than equilibrium sign. They wouldn't mark you wrong, but you should do it for yourself because this reaction does go 100%. You don't have to worry about an equilibrium thing. It's going to go 100% to have that hydroxide combine with the proton of the hypochlorous acid to make HOH, water, our liquid. And then we would have our sodium hypochlorite. Now let me make a little diversion here because sodium hypochlorite and hypochlorous acid are pretty common chemicals, and you should know a little bit about them. I'll put this picture up first because this is the one you might have seen last where you ended up getting some sodium hypochlorite in bleach. If you first to get any product that has a bleach listed to it, most of the time its active ingredient will be sodium hypochlorite dissolved in water. And this is a typical percentage, and it reacts with the water to make some hypochlorous acid. You can't have sodium hypochlorite without hypochlorous acid simultaneously. They have an equilibrium. I'm going to bring up the Wikipedia page on it, which is all about this, and they say it's commonly known as bleach. The sodium hypochlorite isn't all that stable, though. They usually have it as a hydrate, and even then, it decomposes pretty quickly. That's why they put it in water in solutions. In a solution, it's more stable than it is as a solid. See its uses as bleaching, cleaning, and very importantly, disinfection. This hypochlorous acid version, bleach, and the hypochlorite ion itself is excellent in terms of antimicrobial activity. It is one of the surest things to kill bacteria. So if you have something where you're worried about contamination, bacteria and viruses, a bleach solution is going to be a safe, not a safe choice, but a good choice. The only thing is that you should end up rinsing afterwards because you don't want this bleach to be left on a surface for all that long. Hypochlorous acid and sodium hypochlorite have saved many thousands of people, maybe even millions, because it's one of the best ways of stopping cholera. Here, if you look up cholera, which is a pandemic that is horrid, that we've had around for centuries, the clean latrines, clean surfaces, 1 part household bleach and 9 parts water. If you look at cholera, you see bleach, bleach, bleach mentioned constantly because this is the way to stop this horrible disease. While bleach is one of the least expensive disinfectants, it does have some hazards, and the major hazard is mixing it with other common products. You should only use bleach in its dilute solutions without mixing it with anything else. If you add it to vinegar or any type of acid, or if you add it to ammonia or some ammonia or some other ammonium salts, you produce poisonous gases, and there are quite a few people who get injured because of mixing bleach with other things. So use bleach in its diluted form, and if you use it in pools and stuff, be very careful, read the instructions, don't mix it with anything else. That's a hazard. So a bleach solution is what we have here, one that can clean stains and save lives. But unfortunately, this equation would be wrong. If this was an FRQ question, and it was, if you wrote this down, you could get 0 points, which would be sad because, it's correct, but you missed this where it says net ionic equation, and you have to be able to write a net ionic equation. I'm going to go through this again, and I'm going to say, indeed, we have HOCl aqueous. And you say, well, this is an acid. Shouldn't I write it as an ionized acid? If it was a strong acid, yes. However, this is a weak acid, and it stays together most of the time, so you write it that way. You write it as a molecular substance. Then we have our sodium hydroxide. This is where things start falling apart. All sodium compounds are soluble. So you don't get sodium hydroxide really in a sodium hydroxide solution. You get sodium ions and hydroxide ions floating around. The only way you get sodium hydroxide sticking together as an ionic substance is a solid, as a white solid. And of course, it still reacts and it makes water, and you don't write water as being ionized. Kw is 1 times 10 to the negative 14, so the water is primarily H2O with very, very little H plus, no H minus. So you write it in the predominant form. But sodium hypochlorite, on the other hand, is here ionized. It has the sodium separated and the hypochlorite. All sodium compounds are soluble. If you have a sodium, whatever aqueous, this sodium becomes an ion. Now, when we say net ionic equation, we mean that you get rid of ions that don't change, or anything that doesn't change. And here, the sodium is here, the sodium is here, so that doesn't change, and so it can't be used in a net ionic equation. Here's the only things that we would end up writing. We would write the hypochlorous acid. Now, I strongly advise not using aqueous, even though it is. We would also end up having our hydroxide ion. The sodium is eliminated again. And again, I didn't write aqueous because if you make a mistake and write down L, which would be incorrect because this is in a solution, the grader would have to mark you wrong. This is a case where if you give too much information, you shoot yourself in the foot and you lose things. So, I mean, it is nice, and if I was being really perfect, I would write aqueous for all of these. But on an FRQ, save yourself. You don't want to mess things up. Don't put it down unless you have to, and you don't have to ever. We still have water. Again, that doesn't ionize, so it is new. And we forget about the sodium in the product. This is the net ionic equation. Of course, I wouldn't write all this stuff down. I would see HOCl. I'd say, okay, that's a weak acid. Sodium hydroxide, sodium is always an ion that doesn't react. It's going to be a spectator ion. And as a spectator, you don't include it in a net ionic equation. And I would have just written OH minus. Of course, you'd have to know that the OH has a charge of -1. And of course, we know that this would produce water. A acid and a base produces water, and you would have to figure out the hypochlorite polyatomic ion. So to get this point, remember, net ionic equation. This arrow isn't absolutely necessary, but I would omit the aqueous and liquids just for your own safety, and of course, get rid of spectator ions. So we got this one taken care of. And the next part of the question will be answered in the next video. Okay, cue the music.